Good day, stats students. So today we're going to talk about section 2.1, different types of data. Let's see if make sure my microphone it is up. Okay. And so we have different types of data that we're going to talk about. And so the very first thing that we're going to talk about are variables. All right. So with variables, we're used to, let me get my pen out. We're used to seeing things like this in algebra, like 2x plus, 4 is equal to 10, and we would say x is a variable, but it stands for a specific number in this equation. Okay, that's not how variables are handled in statistics, or for that matter, the real world. Okay, outside of say an algebra course. Okay, when we're doing an actual study, the way that things have to be organized very well, and so because for one person you might have 20 different variables from that one person. Okay, so this is the way it's going to be organized, and you'll see this in lab. All right. So maybe you have here variable 1, and you got variable 2 and variable 3, so on and so forth. And then, so maybe variable 1 is gender, and so so what's going to happen here is that you're going to have these rows, and the first row will represent the first person, and so maybe the first person is a male, and he is 19 years old, and he has 2 siblings, and so on and so forth. So you might collect all kinds of variables. Okay, then you go to the second person. Maybe the second person is female and is 23 and is an only child. Okay, and it has 0 siblings. And so notice how the variable 1, gender, that would all line up there. Age, number of siblings, okay, so on and so forth. And so that's the way the data is going to be organized as far as variable goes. All right, so what is a variable here? It's any characteristic observed in a study that can change from person to person or thing to thing. Okay, so things like marital status, height, weight, IQ, all examples of variables. So notice variables, I have gender over here. Notice it's not even taken on a number, and that's okay here. Actually, we have that happens a lot, okay? And we're going to talk about those here in a second. So, a variable can be classified as either what? Categorical. Oh, I sort of made a boo-boo here. That's all right. We'll get the eraser out, and there we go. Okay. So there we go. So variables can be classified as either categorical. Now that's what the book calls it. Okay, that's what the book uses. But you might get into another class, and it might be called qualitative. And so whenever something is possibly called something else in another class, I will bring that up to you throughout the course. All right. So don't panic if you get into another course and the professor starts talking about qualitative variables. That's just categorical. Okay, now I'm not going to use qualitative ever again because this book uses categorical, so that's what I'm going to use. And what are those? Those are the non-numerical variables. Then you have quantitative. Quantitative, what's the root word for quantitative? Quantity. Okay, quantity. That means the variable produces a number. It's numerical. Okay, and so there's another list there. What types of variables? Okay, you have categorical and quantitative. So let's talk about categorical variables then, and some examples here. So you got your gender, okay. Then you got your religious affiliation, Catholic, Jewish, Protestant, whatever. Then you got types of residence. So like, where do they live? Do they live in an apartment, a condo, a house, in a dorm? Belief in the afterlife, yes or no? And so notice yes and no's types of answers, which would be categorical. Okay. All right. How about quantitative? So, variable is called quantitative if the observations take numerical values that represent different magnitudes of the variable. Ooh, what does that mean? I put here means that there has to be some sort of scale. Okay. And so, what I mean by that is that if somebody or something produced a variable and produced the number 8, and for that same variable somebody else produced the 4. You know that this first person is twice as much as the second person with regards to that variable. Okay, there's some sort of scale, there's some sort of magnitude toward with it. Okay. Okay. And so some examples here. You got age, number of siblings, annual income. Okay, those are all examples of quantitative variables. Now I got to warn you of something. Pay attention here to the fourth one. I said be careful. Social Security number. All right. So Social Security number. If somebody had a Social Security number of 200000000, and somebody else had a Social Security number of 100000000, does that mean that the first person is twice as much as the second person in some way, shape, or form? No, of course not. And so there's no scale to it. Okay, there's no magnitude to them. Okay, it's just identification. We could have used letters instead of numbers here. Okay, to identify people. All right, and so Social Security number, believe it or not, is not a quantitative variable. It's actually categorical. Okay, so just because it takes on a number, you got to think: does the number actually represent a number, or is it more of a sort of identification? That's what happens with the second one. So month represented with a number. So, for instance, I don't know, October. October is what 10. Okay, and so a lot of times if we are signing some sort of legal document, instead of writing in October, you might just write in 10 to represent October. February is 2. Okay, so does that mean somehow October is 5 times as much as February? No. Okay, there's no scale to it. There's some sort of natural order to it, but it doesn't have a scale to it. So that would not be quantitative. Okay, that's categorical. And plus, you can always switch back to saying, instead of saying 10, you could say October. And instead of saying 2, you could say February. All right? So be careful. All right? Now, are we going to purposely try to mess things up? No, we're not going to. We're not going to try to make it any difficult or anything. But I'm just warning you that could happen if you're doing some sort of study, and sometimes that trips up students. Okay. Now, there's 2 types of quantitative variables. So there's discrete, and then there's continuous. So here's another list, small list, but another list in Chapter 2. So 2 types of quantitative variables. We have discrete and continuous. So let's talk about discrete. Okay, so this is discrete. Quantitative variables discrete if its possible values can be listed, such as 0, 1, 2, 3, and usually we can count these variables. So for instance, you could go ahead and count then the number of shoes that you own, okay, or the number of cars that you own, or the number of, if we got into a classroom, we could count throughout the day the number of people in that classroom, okay, and so there you go. There's discrete, and so it's usually going to just take on a nice whole number, such as 0, 1, 2, 3, okay? Usually. Now, I say usually because it technically can be -2, but we usually don't run into negative numbers too often. And so as values for a variable, we can, but we usually don't. How's that? So discrete variables have a finite number of possible values. Okay, so here I gave you some more examples here. Number of pets in a household. So we can go to different households and we can say, okay, how many pets you got? Okay, number of children in the family. So we can go into ask a family how many children is there in the family, and go to different families. And so notice it's a variable. It's going to change from family to family. Number of foreign languages spoken by an individual. Okay, and so on and so forth. Okay. Notice here in the English language, notice what all of these start with. Now, this is kind of a clue that it is discrete. You start with number of. Usually, not always, but usually we are talking about discrete, because when you say number of, you're asking for a very distinct number at that point. And it's usually you're basically saying, give me the whole number for this. Okay? And so it's just kind of a clue that tells you that it's probably discrete. Okay? About the continuous variables. Quantitative variable is continuous if it can take on any value. And that means you're bringing in all the decimals. Okay? So examples. You got height. Okay, and so so you might say that you're 5'10". Okay, but are you exactly 5'10"? No, you could take that out several decimal places. Okay, and so you could you could change 5'10" into 70 inches, and then take it out several decimal places after that. Okay, how about weight? Well, do you weigh exactly 160 pounds? Maybe you weigh 160.24, and that's about as detailed as a scale as you're going to get, on your scale. But it can take on decimals. Temperature, right? 98.6. Blood pressure. Age. Oh, this one right here. This one always messes up students, and that's okay. That's why we're bringing it up. So age. So if I ask you your age, I think everybody would be asking for a nice whole number, okay? And so if I asked you your age and you said 18, that's very acceptable. However, just because you answered it with a nice whole number doesn't make it discrete necessarily. And believe it or not, little kids help us understand this a little bit, believe it or not. So any of you have kids or have little nieces and nephews, and when they're really young, okay, you say, "Hey, Tommy, how old are you?" I'm 3.5 years old. They don't say 3, right? They say 2.5 or 3.5, right? And so that makes sense to us, believe it or not. Why? That's just saying that they're halfway through the year. Why? Because age is just a form of time, okay? So even though we would write it as a whole number and it sounds very discrete, okay, we could, if we could add a decimal to it and it still makes sense to us, it's probably continuous. All right, it's probably continuous. And if you think of age as time, okay, all of these have something in common with each other, other than they're all continuous. Okay, and that's what they're all measurements. Notice we have to measure your height, you have to measure your weight, temperature, blood pressure, and time. We measure time. Okay, and so we don't count those things. We have to measure them. Why? Because we can't physically count those things because they can take on decimals. Okay, we as humans only count 0, 1, 2, 3, 4. Okay, and so we don't count 98.6 or a weight of 160.4. We have to measure those things. Okay, we don't count them. Okay, so if it's a measurement, can add a decimal to it. It's probably continuous. All right, so identify the variable type as either categorical or quantitative. All right, let's see what we got here. Number of siblings in a family. So number of siblings in a family. All right, that sounds like what? That sounds like quantitative. Okay. County of residence. That sounds like what? So how would you answer? Just ask yourself, how would you answer it? Do you live in? Let's see. I live in Cuyahoga County. My son, he goes to Bowling Green. That's Wood County. Then you have Summit and Stark around the University of Akron. Okay, so that's categorical. Distance in miles of commute to school. Quantitative, right? Marital status. Categorical. Okay, so hopefully that's stuff that makes sense to you. How about let's identify the following variables as either continuous or discrete. Okay, and so now here all of these will be quantitative. So length of time to take a test. Length of time. Think about it. Did you say continuous? Length of time? So time. We have a clock, okay, that we measure it with. And so we could always say, instead of saying it took us 42 minutes to take the test, it took us 42.683 minutes. Still makes sense to us. Can add a decimal. Number of people waiting in line. Oh, number of people. Okay, sounds discrete to me. Number of speeding tickets received last year. Number of, we can count those, 0, 1, 2. Hopefully they're all 0, but that's going to be a variable and it's going to be discrete. Okay. Dog's weight. So we can go all different dogs and stuff and weigh them, and so weight is what? That's continuous. Okay? So hopefully you got a handle on discrete versus continuous. Okay? So let's talk about proportions and percentages / relative frequencies. And so I know this can get frustrating in mathematics sometimes, and this happens in statistics also, that we have kind of the same name for exactly the same thing, but you might just see it in a different form. It's kind of what is happening here with proportions and percentages, and for that matter, relative frequencies. So I'll explain what I mean. So the proportion of the observations that fall in a certain category is the frequency of observations in that category divided by the total number of observations. Wow. Okay. You know, you read that sentence and you go, it probably is harder. It sounds harder than what it is, right? I bet you most of you know how to calculate, if not all of you know how to calculate a proportion. But and then the percentage is the proportion multiplied by 100, and then you throw your percent sign after it. So now we're going to have to do this quite a bit in this course, okay? And so you might, if you're not good with this, you might want to review. So things like if you had 0.3, that would be considered a proportion. Okay, now how would we, that's 0.3, okay, how would we change that into a percentage? That would change into what? 30%. We would move the decimal point over 2 spots and throw our percent sign down. Okay, so 1, 2, okay. And so sometimes this messes students up when they when you take it out more decimal places. So 0.04, that's going to, see, we move the decimal spot 2 spots here. We throw down our percent sign, so that would be 4%. Okay, but I think the ones that really get students is when they start seeing stuff like this, or they start seeing stuff like, that's supposed to be a 0. Let's say 6, 4 here. So let's say that we had this, so we had 0.001. What would that translate into a percentage? Well, let's see. We're going to move the decimal place over 2 spots. And so what are we going to have here? We're going to have 0.1, right? And then we throw our percent sign down. Okay, and then this one down here, we'll move it over 2 spots. So what do we got here? We have 0.64. Oh, I did a horrible job with the percent sign. Sometimes hard to do with my keypad here. There we go. That's supposed to be a percent sign there. So 0.64. So we have to translate between the two. Okay. So now proportions and percentages are also called relative frequencies, and that's what can be frustrating about this. And so, all right. So when you are doing your homework, and WebAssign says, "Give me a proportion," they want a decimal. Okay. Proportions are decimals, okay, and that's what they're expecting there. Okay, could you put it as a fraction? True, but that's hard to put into a computer program like WebAssign, a homework platform like that. So when they ask for a proportion, just think we want a decimal, and then percentages are obviously percentages, okay. But both of these can be considered a relative frequency, and that's the kind of the frustrating part about it, is that these are basically all saying the same thing, just that they look maybe slightly different. One's a decimal, another one's a percentage, another one could be a fraction or whatever. Okay, but they all mean exactly the same thing. So we can make a table, specifically a frequency table, and list the values for a particular variable, all right, together with the number of observations and or relative frequencies for each value. That's easier than what we think here. So, sorry, that was out of order. It says here, a basic statistics class was recently asked the question about their class ranks. The following were the responses from the students. And so we have sophomore, freshman, senior, junior, sophomore, okay, junior, freshman. Okay, we want to make a frequency table out of this. And so, okay. Actually, I kind of backed it up a little bit. What is the variable of interest here? So what is it? It would be class rank, okay? That's categorical, okay? What type of variable is it? It's categorical, all right? And then, remember, proportion is part of the total, and so we're trying to see what proportion, what part of the total is freshman, what part of the total is sophomore, what part of the total is junior and senior. Okay, and keep this in mind that proportions have to be between 0 and 1. That's all that means there. So now, I know sometimes that these signs right here, remember that this is less than or equal to, less than or equal to. These signs can really mess students up, okay? And I've heard all kinds of strange things that teachers have told their students over the years. This is the way I want you to think of it if you have problems. Now, a lot of you may not have problems with reading this, okay? But for those that do, think of it this way, okay? That physically, where is the word proportion being? Where is it? It is literally sitting between what? 0 and 1, okay? And that's all we're trying to convey to you, is that proportion literally sits between 0 and 1. And so it's going to take on a number somewhere between there. And the only thing that you have to worry about with the sign when it's like this is that, do you have the equal to sign here? And we do. Since we have the equal to sign down here, that means a proportion can take on the value of 0. And since we have the equal to sign down here, that means a proportion can also take on the value of 1. So we're saying proportions are between these two values, and it can take on 0 and it can take on a 1. If we didn't have an equal to sign, okay, that means, so it didn't, let me say it again, let's say it didn't have an equal to sign down here, okay, and it was just less than, well, that means then whatever this is can't take on the value of 0, okay. Now if we translate this into, so this is more of a decimal form here, think of it this way. Over here I changed it into a percentage, and so 0 translates into 0%. And what does 1 translate? That translates into 100, all of it, all of something. Okay, 100%. All right, so we're going to create a frequency table here. And so here it is. And so if you go back to the data there, we had 2 freshmen, 3 sophomore, 4 juniors, 1 senior. We had a total of 10 people. Okay, so there's your frequency. It's just the count of things, okay, in your data. And then we take, to calculate the proportion, we take our frequency of 2, divide it by the total of 10, and so 2 divided by 10, and I'm going to translate that into a decimal. You can put that in your calculator anytime you wish, okay? And don't think that you have to do this stuff in your head, because you do not. You can translate it with a calculator. 3, right, divided by 10 to get 0.3, 4 divided by 10 to get 0.4, 1 divided by 10 to get 0.1. When you add these up, these should add up to 1. If you translate this into a percentage, 0.2, what is that going to translate to? 20%, 30%, 40%, 10%, okay? And what do we get? We get 100%, okay? So just to make sure, here was freshmen and freshmen. So we had 2 freshmen, right? Sophomore. We had 3 sophomores. Juniors, 1, 2, 3, 4. And we had our 1 senior. Okay? Okay. Last thing that we're going to talk about here in this section is the mode. And either the mode is either the numerical value or the categorical, but honestly, this is usually thought as numerical only, but technically, in a very technical sense, the mode could be categorical, but usually it's not thought of as categorical. It's usually just thought as numerical. The highest frequency in a data set. So here is a data set, and it has various numbers in here. And so can you look at this and see which number you think has the highest frequency? So let's see, 5. We got 1, 2, 3, 4. So 5 has a frequency of 4. 3 has a frequency of, let's see, that's only repeated twice. 6. Here's a 6. Here's a 6. That has a frequency of 2. 8 has, I think, just 1 there. And then we have a 2. That's just once. 7, 0, and 1. They're just once. And so which one number got, repeated itself the most? And that would be 5. And so we would say the mode. Okay. Oh my goodness gracious! Look at that. That's awful. That's right. Mode in this situation is equal to 5. Okay. Can you have more than one mode? Yep. If that's the case, you would just have a tie between numbers, all right? And both of those would be a mode. We would call that bimodal. Two modes, bimodal, okay? When you just have one mode, that's called unimodal, okay? And so for the most part in this class, I think we're just going to be dealing with data that's unimodal, just has one mode. And we're going to see that sort of in the next section when we deal with graphs. All right, so thank you for your time.